Hi friends, welcome to my channel. Today in this session, we'll see how to run a simple program, Verilog program in Xilinx Vivado tool. So when you double click on the Vivado tool on your desktop, this page gets open. In this page, you can see on the left side, quick start. Below that, you have the create project. So whenever you are creating the project for the first time, you have to click this option. If the project is already created, then you can go to the open project option. So as we are now creating the new project, so we'll go for create project. So when we click on the create project, a new pop-up window appears and we have to simply press next. Then it asks for the project name. Here we have to give the project name. So today we will see how to write a Verilog code for D flip-flop. So I will take the project name also, D flip-flop. And it's asked for the location where the project has to be saved. So you can mention the project name, the path where it has to be stored. Then click next. Then this next page, we will be asked for the selection of the project type. So here we are selecting the RTL project because we want to create a new project. We can create an IP integrator, IP block, and all this we can include in the RTL project. And these are the other options which we can go for if we are already created with an RTL project. So as of now, I'm selecting the RTL project and click next. Then we can add the files if the project file module is already created, a Verilog file or a VHDL file is already there in your system. You can select add files. And if a folder is there already with some files, then you can go for the add directories. Or if you are for the first time you are creating a Verilog file, then you need to select the create file. So here I am clicking on create file. And at the bottom, we have to select the language in which we are going to write the hardware description language code. So here we have two options. One is VHDL and the other one is Verilog. So I'm selecting Verilog. And it is also asking for the simulator language where we have the options VHDL, Verilog and mixed. By default, it is selecting mixed. So I'm keeping it as it is without changing anything. So let us now go to create file. So here you can give the module name. So module name is here D flip-flop. So I have taken DFF, or you can take any other name for your module. Then if you want to create one more Verilog file, then you can go for create file. Otherwise, click next. Then it is asking for the constraints. So as of now, we are not going into detail about the constraints. So we will skip this step. The next step is selection of the part and the board. So this is for So we can select the part and the board on which we want to dump our Verilog code. So here at the top, you can see the option boards. When we click on it, it shows all the boards available in this tool. So you can select any of the one which you like. And any part, because we are not specifically now dumping any code on the FPGA, so we can select any one. But if you are actually dumping the code on the Verilog FPGA board, then you have to select the one which you are using. Now, based on the part, like how many IO pins are required, how many LEDs are required for your project, flip-flops, B block RAMs, you have to select the part of the board. The next option. Now it shows the project summary, what we have selected in this. Then click finish. Now we have declared the module name, but we have not given any inputs and outputs, and module instantiation is not done. So here it is asking for the input ports and output ports. So here you can simply mention, or you can later also mention. So as of now, I'll mention here D input. If it is like 3 bits or 4 bits, then you can mention what type, how many bits. So here it is not required because we are taking D input as a single input. Then we have output Q and a clock. Clock is input, then Q. Q is our output port. So select output. So we have these 3 options: input, output, and in-out. So Q is output, D is input, clock is input, and that's it. If you want to add any of the input here, you can add it, or you can later in the program also, you can add the inputs. Now we can see on the left side in the source block, D flip-flop is created with the .v extension, Verilog.v. So when you click on, double click on this, you will see that a module is created with the input D, clock is another input, and output Q. Now we need to write the code for it. So here I will take it, I'm using a non-blocking mode. So I will use here reg Q. I'm mentioning here only output. Then always at the rate of POSH clock. Means whenever the clock transits from the negate to the POSH on that time, the D flip-flop will check for the input and it would change its output. Then begin. Q is assigned D. Simply end. Now on the right side, you can see it shows that no error is there in the code, because here we can see a green color mark. If I'll remove any semicolon or anything, we'll find that if there is any syntax error, it will be shown here itself. So this is one of the advantage of Vivado 2. So now we'll save the project, Control S, and then we can go for the simulation. Simulation is the process where we give the input and we check whether the circuit is functioning properly or not. By giving the input, we are expecting the output. So we'll go on the right side, simulation, run behavioral simulation. There are 2 ways of simulating the code. One, you can directly give the inputs, or you can write the test bench. So here we are now giving the direct inputs to check the output. So select the input D and right click, go to the option force constant, change it to binary, force a value. I'm taking D value as 1. Then go to the another input, clock, right click on it, force clock, leading edge 1, trailing edge 0. Okay. Then at the top we have an option run for 10 microseconds. So click on it. You can change the input again. Right click on D, force constant 0. You can change it to binary. Okay. Again, you can click on run for 10 microseconds. Now you can expand this window and you can check for the outputs. A D flip-flop is also called a data flip-flop because whatever the input you apply at the input of the flop is the same output you will get. So if D is 1, we are expecting the output is also 1. So let us see whether we are getting it or not. Yes, when D is 1, Q is also 1. When D is 0, Q is also 0. So our D flip-flop is working properly. Now, we can go for the synthesis. Close this. Close the simulation. Then we move to synthesis. Before the synthesis, we have RTL analysis on the right hand side. So in that we can go to the schematic and we can see what schematic is generated for the code which we have written. In my upcoming videos, we will discuss about the constraints, how to add the timing constraints in Vivado tool. So this is a D flip-flop. Clock is one of the input, D, and the output Q. Now we will move to the synthesis. Run synthesis. So here we can see the TCL, this one, that it is running. Synthesis is a process in which a netlist is created for our design. So when we give the timing constraints, that time we can see in the bottom part of the screen, we have WNS, TNS, and WHS, THS. These are all related to the timing constraints, worst negative slack, total negative slack, and all. So that in my upcoming videos, I will be taking the timing constraints. That time we'll see what these are and how to rectify if any error is present in our design. Now you can see that in the synthesis result, it is showing flip-flop 1 because we have created only a single D flip-flop. So it is only resource used by it is only a single flip-flop. Generally, combinational circuits are implemented in LUTs, and this memory registers are implemented as flip-flop. So here we can see a D flip-flop is taking only one flip-flop. This is the device utilization report also. So now in the synthesis design, we can see, we can go to the bottom option. There we have schematic. So we can click on schematic and we can see what logic is input for the code which we have written. So this is the same. We have a clock which is connected to the D clock input of the D flip-flop and a D input which is connected to the D. And we have the output Q. So I hope this will help you to understand the tool. And this is a simple video about the D flip-flop. So in my upcoming videos, you will find much more circuits and we'll try to use that constraints also. Thanks for watching.